like, share, and subscribe to my YouTube channel. Thank you for your support. Hello guys, welcome back. This is YouTube channel. This is Jonathan Goldfish. So for this video today, we are going to enter the new chapter, which is the chapter 6 series. Okay, so in this chapter, it consists of 3 subtopics, which is the binomial expansion, arithmetic progressions, and geometric progressions. So two subtopics in this chapter, okay, arithmetic and geometric progression, is actually under series, okay, which you have learned both of these from your secondary school. Okay. The only thing that you have to learn in the matriculations, especially in A levels, which is the binomial expansion. Okay, because it consists of selections. So let's dive into the first subtopic now. Binomial. So the first thing, before you get to know the binomial expansion, is what is the factorial? Okay. So how does it represent? N with the exclamation mark. Okay. So this exclamation mark comes from an invention of the mathematicians. Okay, because of he is lazy to write out the multiplications. Okay, so here's the definition of factorial. N factorial equals to n times its original value minus 1 times minus 2 times minus 3. Okay, keep timesing, keep multiplying until you get the last product of 1. Okay, or we can replace my sentence as n times n minus 1 times n minus 2 all the way around times 3 until times 3 times 2 times 1. Okay, so this is actually the arrangements. Okay, so for the n plus 1 factorial, okay, so just following the definitions of the n factorial, it is n plus 1 times n minus 1 times, keep multiplying until you get the product of 2 and 1. Okay, so after this proving, okay, we can conclude that n plus 1 factorial is equal to n plus 1 times n factorial. Okay, so this one, please highlight it, and you must get what this means. So let's take a look at the examples. Okay, to give you the warnings before you make any careless mistakes. So let's take an example of the 6 factorial divided by 4 factorial. What is it? You shouldn't treat it as the integers, because of 6 factorials has its definitions of 6 times 5 times 4 times 3 times 2 times 1. Not cancelling like this for the factorial simplifications. Okay, so it is not 6 over 4 cancel out to get 3 over 2. Okay, this is the wrong definitions, the wrong simplifications of the expressions. So this is how to simplify the factorial expressions properly. So which is the lowest one? 4 factorial. Which is the highest one? 6 factorial. Okay, so since the 6 factorial is the highest one, write out its multiplication out, which is 6 times 5 until you get the terms of the 4 factorial. Okay, so as you can see, the 4 factorial term has seen in your numerator. Okay, it can be cancelled out with its denominator. 4 factorial cancelled by the 4 factorial to get 6 times 5, which is 30. So this is the correct and proper way, and also the neat way to simplify the expressions with the factorial term. Okay, so the next thing, it is the combination formula, which can be represented as like the vector form of the NR. So every student misunderstood that this is the vector NR, but actually it is wrong. Okay, not wrong, but different identifications. So the vector NR refers to NCR. Okay, so what does C meaning? What does C mean? It means combination. What is combination? Selections, which has a definition of a n factorial divided by r factorial times n minus r factorial. Okay? So it means that out of the n, you choose r. How many r to select from n? So this is the syllabus for the probability and statistic one. This we will cover in the paper 5 lecture soon. So stay tuned for my further updates. Okay, because of in your AS examinations, you are going to take this pure mathematics one and the probability and statistic one. Okay, which is paper 1 and paper 5. Okay. No matter which series are you going to take. Okay, the next thing is the NR notation is also closely related to Pascal triangle. Okay, C. So when n equals to 0, you have no choice. You only have one. Okay? When you have the 1, which means that you only have the a plus b expression. When it comes to 2, you have the a squared and b squared. And don't forget there's another possibility of twice ab because of, here is the example, a times a plus b times a plus b. So this is the proper expansion, right? So we have a squared and ab times plus ab times again, expand it all to get b squared. So as you can see that there are two selections of the AB. So combine it together. So this is the proper expansions of the two brackets form. Okay, this one you have learned from the secondary school. So apply this inside the past. Apply and relate about this expansion. It is called binomial expansion with the NCR term or notation. Okay. So for your syllabus, the n must be positive integers. Because of this Z refers to n subsets to integers only. Okay? So in your A2 syllabus, which is the chapter 1 algebra, you will learn for the n is not only positive integer, but negative integer or somehow fractions. Okay? So for the n equals to 3, it is a cubed, b cubed, but we have 3 ways. We have 3 selections of the a squared b and a b squared. So which means that each coefficient is closely related to the Pascal triangle, which is 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. Okay, I believe that you have identified or seen about what is the Pascal triangle from your lower form of the secondary school. Okay? And until you step into the phase of the matriculations, you can relate Pascal triangle is actually coming from the NR notation. Okay? So summarize all of these. Okay, for the binomial theorem for the a plus b bracket to the power of n, where n is the positive integers, you will get this term times n. Okay, because you have only a way to list out the only term of the an. Okay, plus n c1 a to the power n minus 1, and the degree of the b starts increasing, where the degree of the a decreases from n to 0. Okay, from n to 0. Where for the last term is r equals to n. Okay? So for this summation behind here, it's just for your understanding, or this is the recurrence deduction. Okay? So of course, binomial theorem for this formula exists from the MF19. So let's refer to MF19. Okay, here it is, as I have highlighted over here, where n is the positive integers. Okay, so for the formulas that are highlighted over here, this one, okay, for the AS phase, you don't touch it first because this is the A2 syllabus. Okay? So no worries when you're dealing with the binomial expansion questions in your actual external examinations. Okay? So we have ended the discussion for the 6.1, the one of the subtopic which is crucial in this chapter. Okay? So we have ended the discussion of this subtopic. Let's move on to the subtopic 2, which is the arithmetic progression. Okay, what is arithmetic? Arithmetic means addition and subtractions. Okay, so apologize that I don't have any extra notes, but please write it by yourself. So for the A, what is A? Arithmetic means plus minus. Okay, so it defines as the sequence which each term differs by a constant value. So what does the constant value refer to? It refers to common difference. So how to get common difference from the given series? Given that the series is arithmetic progressions, by taking Tn minus Tn minus 1. Okay? Also, the arithmetic progression has the first term that usually denotes as A. Or you can call it as T1. Okay? So the few common terms seen in the arithmetic progression, like A plus D, A plus 2D, okay? Recurrence, fundamentally, until you get the last term of A plus n minus 1, D. So for the n term of the arithmetic progression, it is Tn equals to A plus n minus 1, D. Okay, so here's the proof. For example, the term 1 is 6. So 6 equals to 6 plus 0, right? Okay, 0 can equal to 1 minus 1 times 6. 0 times 6 is 0. Okay, so for the second term, it is 12. So which means that 12 is the 6 plus 6. Okay, so it is actually the first term plus 6, or the 6 plus 1 times 6. Okay, so which means that following the recurrence, fundamentally, we have the deductions of it is an arithmetic progression or arithmetic series. So we can summarize the formula, therefore proven. Okay? Or we can say the Tn is equal to Sn minus Sn minus 1, where the Sn equals to the sum of the first n terms. Okay? Like sum of the first 3 terms is 6 plus 12 plus 18. But what I want is the term 3. I only want 18, right? So I have to get rid away the 6 and 12. Okay? I want to get rid away this one. So to get the term 3, it is S3 minus S. This is the sum of 2, right? So S2, which is this S3 minus 12 minus 6. Okay? So therefore, this formula is also proven. Okay? So there's another proof for your understandings, as my notes has shown over here. Right? So I may erase this away. Okay, because this is just for your understandings. Okay, sum of the first n terms. Here is the next formula you should know, which is the Sn equals to n over 2 times, okay, the square bracket of 2a plus bracket of n minus 1 d. So of course, n is the total first n terms. The n means number. Okay, where n can be only integers. A is the first term, D is the common difference. Okay, so here's the proof. It is, okay, Sn can be A plus different, A plus twice different, okay, dot 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 plus until you get the last term. So conversely, Sn can be also the reverse of the sum of the last term until the first term. So these two equations are formed to solve it like the simultaneous equations. Okay, combine these two equations, you get the 2Sn. So as you can see that each of it has the common term of the 2a plus m minus 1 plus d. So which means that each of it has n times of the additions. So combine it into n. Okay, which means that you have n times of the 2a plus m minus 1d to get the twice of the Sn. But we only want the term, we are only to looking for the Sn, right? So divide 2 at both sides to get this formula. So therefore proven. Or to get the Sn for the all terms, okay, we can include the last term. Why does it? Because of twice of a, we have a plus m minus 1 d. So what you can see over here, this is actually the last term. Let's say this arithmetic progression consists of 50 terms. Okay, where 50 is the last number. So last number equals to T50, which carries the first value, I mean the first term of the A plus 50 minus 1, which is 49, and then times its common difference. Okay? So this is the concept you should know. Okay, there's another proof that yeah. So actually I have proof about how does the last term come. Okay? So therefore, this formula is also proven. Okay, so these formulas that I have written by using the magenta colors, okay, also exist from an NF19. Only I label it with a star and NF19. Okay, so we have 1, 2, and 3. Okay, But this formula does not exist from the NF19. You have to memorize by yourself. Okay, so for the mathematics, don't try to memorize. Okay, the sole strategy is do more practices regarding which involves this one. So let's open the MF19, see whether the formula exists or not. Okay, it exists the term for the UN or TN. Okay, but it shows UN as well as the Sn like this, where L is the last term. So candidates should get to familiarize, get sophisticated how to use this formula properly. Okay? So it's very fast. Okay. So we have ended the discussion for this subtopic, arithmetic progressions. So let's move on to the last subtopic of this chapter, which is the geometric progression. Okay, what is geometric? The geo means multiplication and division. Okay. So in the end of this chapter, I'll teach you how to identify whether the series is AP or GP. Okay. So arithmetic progression is abbreviated as AP. Meanwhile, for geometric progressions is abbreviated as GP. Okay, let's enter the GP. So GP is the sequence of numbers for which any term can be obtained by multiplying by certain numbers from a previous term, and also can be division. Okay, if the common ratio is less than 1. So what is the certain number means? Refers. It is common ratio. So to find the common ratio, it is Tn over Tn minus 1. Okay. Also, it has the first term that usually denotes A. Okay. This one I'm not going to explain here too much. So there are a few common terms seen when you are dealing with the questions of the geometric progressions, which is the A times R, AR square, okay, dot, so on to get AR to the power of n minus 1. Okay? But however, for the r, it has the power of this because of it involves the multiplications and the divisions, right? So I think somehow, like the question comes out when it wants to use to solve for the n, okay, you must use the logarithms when it is unsolvable. Just only using the indices simplifications. Okay? So for the n terms of the geometric progression is Tn equals to ARn minus 1. Okay? Well, I forgot to provide the proof of this formula. Okay, let's prove it now. Okay, apologize that I don't have any much time due to my self-circumstance. So given that, I give an examples, a equals to 2 as our first term for the GP. The term 2 is 4, term 3 is 8. So 2 can be 2 times 2. For 8 is 2 times 2 times 2. Right? But since all numbers are 2, okay, instead we can list it as 3. 3. And then 9. 27. No. Maybe I let the common ratio becomes 2. 3 times 2, 6, 12. Okay, so 6 is 2 times 3. 12 is 2 times 6. Sorry, it's 18. Sorry, my mistake. 2 times 9. So what you can see over here, so 3 is actually equal to 3 times 1. So 1 can be expressed as 3 times 0, 3 power 1, and 9 becomes 3 power 2. So what you can see over here, for the first term, okay, a or T1 is 3 times 3 to the power of 1 minus 1, 2 minus 1, 3 minus 1. So we have summarized about the Tn for the geometric series is the first term times the r to the power of n minus 1. So therefore, we have proven about this formula. Okay? So let's enter the sum of the first n terms for the geometric series. It is s equals to a times 1 minus r to the power of n over 1 minus r, or the rn minus 1 over r minus 1. Okay? So how to prove this? Okay, first you have the Sn, a times r squared until you get ar to the power of n minus 1. Okay? And multiply the r for the first set of the equations as r times Sn is equal to ar plus ar squared plus ar cubed all the way until you get ar to the power of n. Okay? But I want to get rid away the terms in the center for each set of the equations. So just 1 minus 2, okay, a minus ar to the power of n, okay. So as you can see, there are ars can be cancelled out like this. Okay, repeat in the same steps to get a minus ar n left. So factorize the a out as well as the Sn outside. Okay, and then we have found the term sum of the first n terms for the geometric series. So therefore, this formula has proven. Okay, but to make these two equations equivalent, well, it's actually the same because of the sign changing. So factorize the minus outside or switch the sign for the both terms on the numerator, in the numerator and denominator, okay, to get this formula. So which means that no matter which formula do you take to solve for the Sn, okay, its value is correct. Right? So there are no restrictions for the R. except the r cannot equal to 1. Okay? So for the sum of the infinity of the geometric series, okay, it involves limits. Okay? So prove that, so here's the proof. Given that the Sn is equal to the formula that we have proven from above, okay, which is also called the summations of it, a times I minus 1, where I starts from 1. Okay, to get one of its addition of the a as the first term. So to get the sum of infinity, replace the n as infinity. Okay, so infinity is an unknown values, but we can evaluate by taking limits. Alright, so the limits as n goes to infinity. Alright, for the only for the r, the modulus of the r is less than 1. Okay, so you can use your calculators to evaluate by yourself. Let's say the r is 0.8 power of n. Okay, as the n tends to a larger value, and how does this number change? Okay, of course it is closer to 0 as the n becomes bigger and bigger, right? So as n goes to infinity, for the r, modulus of r is less than 1. Okay, the r infinite, sorry, there's a mistake. It is not r infinity, it's rn. Okay, please change it over here. Okay, so the rn tends to 0. So which means that this term becomes 0 right now. Okay, so you will have a over 1 minus r left. So this formula has proven. Okay, remember when the question asks you to find the sum of infinity for the geometric series, you must list out this formula as well as what is its restrictions. The restrictions is the modulus of the r is less than 1. Okay, why we can't use the common ratio of the r is greater than 1? Because if you apply the limits, okay, for the r is greater than 1, the summations or the expression becomes diverges. Or we can say it as this summation diverges. Why diverges? Because of undefined. Okay, so for the positive r, or the r is greater than 1, okay, it is increased by the n, when n tends to the larger value. So therefore, the Rn is indeterminable. Okay, so that's why modulus of R cannot be greater than 1. Okay, so I'll repeat the last time. For the sum of infinity of the geometric series, we can't use the R is greater than 1 or its modulus value or its magnitude. Okay, so same as the last subtopic. Okay, the formulas that I have written by using the magenta colors, okay, assist from the MF19 that you own. Of course, the R cannot be 1 because of when you take the geometric series for R equals to 1, okay, each term is the first term. Okay, this is not called geometric series. Okay, so let's open the MF19. Where is the geometric series? So for the geometric series, each term of the geometric series is a r power n minus 1. For the Sn is this formula, but some students prefer the formula of the Rn minus 1. Okay, so these two formulas are the same thing or equivalent. Okay, and for the sum of infinity, you can only use when modulus of R is less than 1. Okay, so therefore, we have end this subtopic. Alright, and this as well as this chapter. So let's proceed to the exercises. Well, this is indeed fast. Okay, time for the exercises for chapter 6. So same as usual, this exercise also consists of the course book and the past year questions. So I'll only discuss the 14 questions for you. Okay, the rest of the question, I need you to try it out by yourself. So let's start from question 1. Express each of the following in terms of n. Right, so remember from F19, the n r in the vector form is equal to ncr, where it carries the definition of n factorial divided by r factorial times n minus r factorial. Okay, so here's the tutorial of the using calculators when you own, if you own Casio FX 570EX. Okay, so for the part A, N2. So what is N2? It's NC2, right? So use the definition of the NCR to evaluate what is the NC2, which is n factorial divided by 2 factorial times n minus 2 factorial. Okay, so this tutorial is for the question 2. Okay, why this isn't applicable for this step? Because of the n value is unknown, right? So use the definition of the factorial. N factorial equals to n times n minus 1 times n minus 2 until you get the multiplication of 1. But since the n is unknown, we can only know about these multiplications, right? Okay, write it like this until you get the same term as the denominator, which is n minus 2 factorial. Okay, so cancel it out for both, you get n times n minus 1 divided by 2. What is 2 factorial? Which is 2. Or if you want to expand, okay, it's up to you. So do it the same way as the question 2. N1, NC1, which is n factorial divided by 1 factorial. 1 factorial is 1. N minus 1 factorial. Okay, which is n times n minus 1 factorial divided by 1. We can leave it blank because of 1 times this is anyway n minus 1 factorial only for denominator. Cancel out for the both sides to get only an n. Alright? So, yeah, it's easy. Okay? So this can be summarized as, no matter how much is your n, okay, its n C1 is n. Or the n C n minus 1 is also n as well. Because of you only have n ways to choose n minus 1 out of n. Right? Same as this one. You can only choose 1 from n, which means that you have n selections. This one I'll repeat in Statistic 1, Chapter 2, Permutation and Combination. So for C, N3, NC3, which is n factorial divided by 3 factorial times n minus 3 factorial. Okay, which is equal to n times n minus 1 times n minus 2 times n minus 3 factorial. Divided by 3 factorial is basically 3 times 2 times 1. We can write it as 6. Alright. And don't forget the n minus 3 factorial from the denominator. Cancel out both terms or the common terms. Okay, in the end you will get n times n minus 1 times n minus 2 divided by 6. So we can note it as this is actually, oh no, I misunderstood that this is as a summation series. Okay, anyway, this answer is valid, right? So yeah, okay, let's move on to the question 2. use the formula of this to find the values of each of following, but we don't have to perform the steps. Okay, in the end, in the exam, you just need to write NCR, like NC1, NC2. Like that is enough for you to obtain the full marks for the binomial expansions. Okay, so this is the conditions for your preparations in the external examinations. Okay, follow the steps over here to get how much of the values, because this number refers to selections or how many terms are present over there. So we must multiply by it. A 10 2 10C2, B 8 2, sorry, it's 8 5, 8C5, C 14 5, 14C3, sorry, it's 14 3, 40C3, D 12 7, 12C7. Okay, so you should get to understand how to use the binomial expansion, which contains the NCR term, because this you will apply in our next video, which is the further maths topic, chapter 1, roots of polynomials. Okay, so the next chapter isn't the pure maths, but for the pure mathematics 1. Okay, so use your calculators, key in any values. Alright, next press shift once and then divide. For using this type of calculator, press shift and then divide sign for the C, and then press the values of 2 or the values of the R, provided that N is at least R. So by right, you will get 45 for 10C2, 8C5, 56, 14C3 is 364, 12C7 is 792. So these are the answers for the question 2. Okay, please verify by yourself. Okay, so when you are calculating this NCR, you must have a good reflex, or you must type it quickly. Okay, to save some time to do other chapters of the questions. Right? So yeah, let's proceed to the question number 3. Okay, move on to question 3. Okay, this is the course book questions. Find in ascending powers of x the first 3 terms in each of the following expansions. Okay, so I don't think we are able to discuss all of the 8 parts of these questions. Okay, instead I'll only discuss only 4 parts of this question only. Okay, so let's start from A. The bracket of 1 plus 2x to the power of 8. Identify which is A, 1, B, 2x. And what is the integers? What is the total number? 8. But it wants first 3 terms. Okay, so the integer n's must start from 0, 1, 2, 3, 4, 5, 6, 7, 8, and so on. Okay, so what is the first term? How to expand first term? 8C0. Okay, 0, 1, 2 only, since it wants first 3 terms only. Okay, so 8C0, write it like this. Okay, but you don't have to write it like this. Okay, because this wastes your time. So identify which is A to the power with the degree of with the highest degree, and for the B, it has the lowest degree, which is 0. Okay, use the same way. Okay, do the same way for the next set for n equals to 1. 1 to the power of 7, because of the degree of the A is decreasing. For 2x, it increases to 1. Okay, for the 8C2, you did the same thing like this. 1 to the power of 6, 2x to the power of 2. And don't forget to write a 3 dot, because of the first 3 terms are the only parts of this out of this full expansion only. Okay, and you don't have to write it all of the expansions. Okay, because this makes you feel troublesome. Okay, so 8C0, 8C1 is very easy to evaluate because of 8C0 is 1, 8C1 is 8, like this. Okay, so 8C0 is 1, 1 power 8 is 1, 2x power 0, so of course this is 1. Plus, what is 8? So 8 times 1 times 2, okay? So this is 8, this is 2, 8 times 2, 16. 16x. Okay, use your calculator to evaluate what is 8C2, but eventually it follows the Pascal triangle, okay, which we will get 28 over here. And 2 to the power of 2 and the x squared, so this is 4, 28 times 4, you will get 112 x squared. And don't forget the plus, dot, 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 and that's all for this. Okay, this is how you perform the workings that leads to the answer of the first three terms of the following expansions. Okay, so carry out the same way for B, G, and H. All right, so let's move on to B. Okay, 1 minus 3x bracket of power of the 10. So it's 10C 0 times 1 power of 10 minus 3x. Okay, so if you want to apply the formula correctly and properly, the minus 3x, you must treat it as b because of its original formula that validates of the use of the binomial expansion, the b, okay, the coefficient of b must be positive 1. So therefore, the b is negative 3x for this case. Alright, so negative 3x to the power of 0 for the first term. What about the second term? It is 10c1. And then 1 to the power of 9, negative 3x to the power of 1, 10c2 plus 10c2 times 1 to the power of 8. And then times the negative 3x bracket square or power 2. Okay, dot, dot, dot. So in external examinations, okay, of course, this type of questions you will meet the most. Alright, so it's better for you to put the 3 dots when the question asks you to find first 3 terms, okay, or the first few terms that the question demands. Okay, so this is best to illustrate that these expansions are just the part of the terms. Okay, so you don't have to perform extra workings. Okay, just write out the result of the answer. So in the end, the first term is 1. The second term is negative 30. X, of course. And then for the third expansion, it is of course positive because of 10c2 positive, negative to the power of 2, it becomes positive. So positive 10c2, 45 times 9. So you get 405 x squared. Okay? So yeah, okay, generally it only gives, generally the terms inside, okay, it only has at most the x to the degree of 1. But sometimes it gives us x squared. So you have to be careful. Okay, what is the degree inside? Okay, to before get to know what is its highest degree for this expansion. Okay, so be aware about it to avoid any careless mistake. So G. Okay, G is the special case because of its term. The expansion inside includes the x to the power of 2. Okay, which raises to the highest degree of 2 inside the expansion, inside the bracket. Okay, so 8c0. Okay, this time is 2, it's no longer 1. So I told you before, apply the formula properly. I mean the formula of the binomial expansion. So the 2 has the highest power for the first term, it is 8. because of the numbers of the degree of this bracket is 8. And for the x squared, it's 0, okay, plus 8c1 2 power 7 x squared power 1 8c2 plus plus 8c2 times 2 to the power of 6 times the x squared to the power of 2 and so on. Okay? So what is 2 power 8? Just use your calculator to evaluate it. So you get 256 plus 8 times 2 to the power of 7, 1024, 1024 x squared plus 8c2 times 2 to the power of 6 is 64. Okay, 1792 and 92 x to the power of 4 and so on. Okay, so I may put a warning sign because of there is an x squared. Okay, for you to aware. Alright, so let's move on to the last part of this question. Part H, 2 plus x squared over 2. There's a coefficient of the x squared, which is half. So be careful. You must expand it with without ignoring the half or omitting the half. Okay? So what is the first term? Oh, sorry, this is degree of 9. So 9c0, 2 to the power of 9, x squared over 2, 0, 9c1, 2 to the power of 8, x squared over 2, power 1, plus 9c2, 2 to the power of 7, x squared over 2 to the power of 2. Okay. So evaluate it by using the calculators. Alright? As I told you before, okay, if you can, try to not to give extra steps. Okay, because this might make you confused. That causes the risk of losing the marks. So for the first term, it's just 2 power 9, which is 512. This is confirmed as the positive. Confirmed. Plus 9c19, 2 to the power of 8, okay, divided by 2, so you get 1152 x squared, of course. Plus 9c2 times 2 to the power of 7 times 1 over 4 because of it is half, okay, half power of 2, okay, it distributes to x squared and the 2, so divided by 4, so you get, wait a second, 9c2 times 2 to the power of 7 divided by 4, okay, so coincidentally it has the same coefficient as the x squared. So if you think, I think I calculated wrongly, but let me check it again. Yes, my calculation was right. So yeah, by right for the part H, your first three terms are 512 plus 1152 x squared plus 1152 x power 4 and so on. Okay, so for the part D, for this you have to aware that there is a coefficient of x squared and take a look at what is the degree of the term x, right? Or the variable x inside the bracket form to be expanded. So yeah, we have ended the discussions for the question 3. So as you can see, I did 4 parts. We did the 4 parts of the discussion of these questions. Okay, it has spanned a page already. So if you can, I want you to I want you to do an extra page if you are using the electronic devices, okay, for the rest of the 4 parts. So maybe I'll create another page for the extra space. Okay, so yeah, we have ended this discussion. So let's proceed to the next question. Okay, let's move on to the question 4. Okay, it's under the course book questions. It is a course book questions. So question 4 is about um, finding the terms of the independent of x in the expansion of this one. Okay, with the 12th degree inside with the x minus 3 over x squared. Okay, so highlight the keyword of term independent of x. Okay, so this gives us the meaning of it only wants a constant, which means that there's an absence of x, which or the x to the power of 0. So you should find it out. Okay, so before we carry out the expansions, I need you to here is the good techniques in answering these questions. So given that there's a degree of 12, right? So list out the 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, of course. 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Okay? So this is the degree of 1 for the x. And what is this degree? This has a degree of the 2. So see if the sum of these 2 degrees of the x must get 0 by right. So here is the sum. So 12 minus 2, 10. 11 minus 2, 9. 10 minus 4 is 6. Yes, 6. 9 minus 5, you get 4. And 8 minus 8, so here it is 0. So square bracket like this, okay, in order to get the term of independent of x quickly and easily. So the rest is obviously not already because the rest of this is negative. So ignore this, okay? Because of the degree of the second term is increasing for the following increase with the values of the n is increasing as well. So perform it like this, x minus 3 over x squared bracket with to the power of 12 equals to, okay, so what is the actual number following the second term, which carries the degree of negative 2. So it's 4. 12c4 times the x to the power of 8 minus, okay, the bracket of negative 3 over x squared to the power of 4. Okay, so as I told before, okay, the sum of the first degree and the second degree must get this one, must get the total degree of inside the expansion bracket. Right? So key in 12c4 in your calculator. Okay, 495. 8 to the power of 8. This is 81 to the power of 8. Okay? So in the end, you will get 40095. That is your final answer because of the question only wants the constant. Why constant? Because of this is the coefficient of x power 0 or the term of independent of x. Okay? So remember, when term independent of x, this keyword is seen or identified by candidates, you should aware that it asks you to find constant. Okay? So yeah, here it is. Okay, let's move on to the next question. Okay, here comes to the next question. So this is the question from the course book. So it is about an arithmetic progressions. Okay, as the second series we have learned. Okay, for the arithmetic progression, the first term is negative 27. The 16th term, th term, is 78. and the last term is 169. And the question asks you to find the common difference and what's the number of the terms. So the number of terms, okay, is dependent from the last term. Okay, write out all the informations that is given, all the informations that are given. A equals to negative 27, T16 is equal to 78. By applying the formula of the AP, so we have to bracket AP. Okay, just follow my way if you want. So the A is negative 27. What is the n minus 1? 16 minus 1 times what is the common difference? To be found. Okay, you don't have to list out what's the formula are you using. Okay, this wastes you a lot of time. So from this equation, you're able to find the D easily and instantly. 78 plus 27 and 16 minus 5, 15. So you will get the common difference of 7. Okay? Now, find the number of the terms. So what is the number of terms? Okay, write the L equals to 169 because 169 is the last term and I want to find the N. So let the L equals to T to the bigger N. So now we are going to find the bigger N over here. First term plus bigger N minus 1 times the common difference of 7 that is found just now. Now let's looking for N. So the N is 29. Okay? So it is best for you to verify your workings and that leads to the correct answer to avoid any unnecessary mistakes. I think I was right. Okay? B. Find the sum of the terms in this progression. How to find the sum of the terms for an arithmetic progression by applying the formulas. So the total of n is 29 over here. So n equals to 29. A is 27. Common difference is 7. So just apply the formula. Okay, usually this step costs 2 marks. Right? S of 29 equals to 29 over 2. Just apply the formulas. That's enough. 2 times negative 27 plus 29 minus 1 times the common difference of 7. And finally, press the key in all the values in your calculators. So you get 2059 as your final answer. Okay, so this is how you apply the formulas that leads to the correct values or the answers that's the question 1. Okay, as well as the B, like find the sum of the terms, you should know how to utilize the formulas properly. Okay, so yeah, that's the end of this question. So now let's proceed to the next question. Okay, this is question 8. All right, so this is also from the course book. Okay, so it's still under the arithmetic progression. The sum of the first n terms represents as Sn of a particular arithmetic progression is given by Sn is equal to 12n minus 2n squared. Okay, find the first term and the common difference. So we have to find A and D. Alright, but it only gives Sn. Right? So you should know that the S1 is equal to T1. So let's find T1. Okay, is also equal to your A. So just substitute n equals to 1 inside it. 12 minus 2. So your A is 10. Easy. But what's the common difference? Okay, to find the T2, so remember that the formula of the Tn is equal to Sn minus Sn minus 1. Okay? Like 1, 2, 3, but I want to get rid 2, 1. So this is the 2, 1 to be deducted from the Sn. Okay? So when you want to think about this formula, think it this way. 1, 2, 3, I just want 3. I want to get rid away 2 and 1. Like this. Alright? Easy. So T2 is S2 minus S1. So what is S2? 12 times 2 minus 2n. Minus the S1. What is S1? It's 10. Okay? So after you keep practicing about for this type of questions, and you won't feel it is complicated. So as you can see, the second term is 6. So the common difference is T2 minus T1, which is 6 minus 10. So the final answer is negative 4 for the common difference. Okay? So yeah, nothing to discuss over here. But still, if you have any confusions about these questions, don't hesitate to reach me out. Okay, through WhatsApp or any other kinds of the social platforms. So yeah, let's move on to the next question, shall we? Okay, question 11. A company makes a donation to charity each year. Okay, so we know that this event is about donation. Okay, so for this event, the value of the donation increases exponentially. Highlight exponentially. By 10% each year. Highlight 10% each year. So which means each year means each occasion. What is the occasion? Donation. Okay, the value of this event in 210. Okay, this occasion starts from 2010 was $10,000. Find the value of the donation in 2016. Okay, so for the year of the 2010, so we treat it as the first term, which is $1,000. Okay, and what is exponentially meaning? It means that the power. Okay, so like e to the power of the n, but it for here it's a to the power of the n, where a is the base, n is the index. This one you should learn from your secondary school, but for this exponential, it only exists in your A2 syllabus. But it only tells you exponentially means this is the geometric progressions. Okay, because of there's a 10% each year, which means that the common here is the increase, but increase by 10%. So which means that for the second year, 201 we represent as T2, T2, 1,000 as the first term, times, no, I mean like, this is the second term, this is the first term. Alright, so originally the T1 is 100%, so we put it as 1. What about the second term? It is 1.10. Why it's 1.10? Because of increases, that keyword. Okay? So which means that for the second year, it must include the first year one. So it's 1.1%. Sorry, it's 110%, which is 1.1. So therefore, this is as your common ratio. So R equals to 1.1. Okay? And what it wants is 216. Alright, so it starts from 210, count as the first, 201, 201st, count as 2. So therefore, over the 6, 216 counts as the 7th term. So T7. Okay, so for the 216, is T7 equals to first term, $10,000 times the common ratio of the 1.1 to the power of 7 minus 1, which is 6. So just use your calculators to evaluate it. So you must give your workings, correct workings, okay, for the examiners to mark. Right? So eventually you will get $17,700 as your final answer for part A. There you go. Okay, for part B. Find the total value of the donations made during the years from 210 to 216, and please matter on the keyword inclusive and total value. So which means this part asks you to find the sum of the first 7 terms, okay, for the total values of the donations. So S7 equals to, what is the A? 10,000. Okay, you can either use the formula of A times Rn minus 1 or the 1 minus R. Okay, it's up to you. So for me, I will use this formula because of the common ratio is greater than 1. 1.1 to the power of 7 minus 1 divided by 1.1 minus 1. Okay, so eventually you will get 94,900 ringgit. Not ringgit, it's dollar. Leave it as three significant figures. Okay, as well as for the part A we have done just now. So yeah, that's the end of these questions. So now let's move on to the next question. Okay, let's move on to the next question, which is the question 12. Okay, it's still under the course book. So this question is about the sum of infinity for the geometric series. Okay, but for this question, I'll only discuss for A and D only. Maybe A and B. C and D, I need you to try it out by yourself. A, 2 plus 2 over 3 plus 2 over 9 plus 2 over 7. So how do you spot that how do you spot there's recurrence and identify this series is geometric series because of, as you can see, first term is 2, second term is 1 over 3, 9 and 27. With the common ratio of the 1 over 3, and as you can see, the denominator of the degree of the 3 in the denominator is increasing its degree. 1, 2, 3, and so on. And the first term is 2. So therefore, the sum of infinity is 2 over 1 minus 1 over 3. Okay, so before we apply the formula of the sum of infinity, verify that the modulus of the R must less than 1. Okay, so since the R is 1 over 3 and 1 over 3 is less than 1, so it's valid to find the sum of infinity. So find it. See how much you get. You will get 3 as your final answer. Because of for the each subsequent term, okay, it is negligible because of the terms for the following terms Okay, it is approaching 0. Right? So this entire thing, we can count it as 1. Right? Huh. Or you can search it from YouTube that to visualize this, you can interpret it geometrically. That's why it's so-called geometric series. Okay? Huh. So for part B. So part B is likely a recurring series because of 1, 0.1, 0.01 plus 0.001. Okay? So it is also equal to 1 over 10, 1 over 100, 1 over 1000. So what you can see is the denominator of the degree of the denominator 10 is increasing its degree. 1, 2, 3, and so on. Okay? So the sum of infinity for the B is, the first term is 1. What is the common ratio? It's 1 over 10. So it's 1 over 10 less than 1? Yes. Because of the modulus of R is less than 1, so it's valid. So just apply the formula of the sum of infinity for geometric series, 1 over 1 minus 1 over 10. Okay? Press your calculators to get 10 over 9 as your final answers. Okay? Huh. But there's another method that to evaluate the the fractions of the recurring decimals. Okay? Instead of identifying it as the sum of infinity of the geometric series, 1.111111 or the 1.111 with a dash upwards over there. Let it equal to x and then multiply by 10 because the 1 keeps repeating. So 10x equals to 11, 11111. Okay, this is equation 1 and this is equation 2. So 2 minus 1, you will get 9x equals to 10. So therefore, the x is the sum of infinity about it. Okay, you see, different approach but same results. Okay, so this method we can call it as the recurring decimal methods. All right, so we have ended these discussions. We have ended the discussion of the sum of infinity questions over here. All right. So the next question is the challenging segments, but we are going to jump to past year questions directly. All right. So let's go. All right. So here's the next questions. After we are entering the challenging segments. So this is the first past year questions among our discussion of exercise over here today. So this is the question of the past questions from 9709, May June 2004, question 4 from paper 1. Find the coefficient of the x cube in the expansion of the followings. Okay. So it wants the coefficient of x cube. Okay, let's solve for the first part. So given that this expansion is 1 plus 2x, okay, bracket to the power of 6. So 6 is the degree. So list out all the degree. So the degree of the first term is 0 since it is independent of x. For the second is x, so we put 1 because of the highest degree of 1. Okay, list out 6, 5, 4, 3, 2, 1, 0. 6, 5, 4, 3, 2, 1, 0. Okay, so the sum of it, of course, is 0, 1, 2, 3, 4, 5, 6. Okay, and if you have any extra time, you may perform. You may list out the Pascal triangles. As we mentioned before, the NCR term is closely related to the coefficients. closely related, the coefficients is closely related to the Pascal triangles. 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6 and 1. So we choose here. Okay, since it wants the x cube, so where to get the degree of 3? So we bracket this one because of the sum of the degree is 3 over here for the r equals to 3. Okay, write down the workings over here. 1 plus 2x bracket power 6 is equal to it's 6c3 times the 1 to the power of 3 and 2x to the power of 3. So from here, it is 6c0, 6c1, 6c2. Okay? So which means that you choose 3 from the 6. Okay? So put 15, and this is 8 x cubed. Use your calculator to evaluate it. You will get 120 x cubed. But is this the end of the workings? Wrong. Because if you leave your answer like this, 120 x cubed, it causes you 0 marks. Why? Because you didn't comply the instruction from the questions, because of questions demands you to find the coefficient of x cubed. So you have to write it again that the coefficient of x cubed is equal to 120. But for these simple questions, you don't have to write it all of the expansions, because this is very troublesome for most of the candidates. But if you want to expand all, okay, it's up to you. But this wastes you a lot of time. Okay? So let's move on to the part 2. Expand this. 1 minus 3x. See, there's a degree of the 1 inside this, the term of 1 minus 3x, times the 1 minus 2x bracket to the power of 6. Okay. So since there's a degree of the 1, so find out which has the sum of degree of 2, which is the third one, 6c2 term. So give it the extra step of 1 minus 3x bracket like this, and then square bracket of 6c2 times 1 to the power of 4, 2x to the power of 2, and then plus 120 x cubed. Okay, since there's a constant 1 over here, which is independent from x as well. So expand it to get, what is 6c2? Oh, sorry, I make a mistake. It's 0, 1, 2, 3. So 6c3 is not 15, it's 20. My mistake. So it's 160. So which means that the coefficient of the x cubed is 160. Okay? So 6c2 is 15 times the 2 power 2, which is 4. So 60 x squared plus 160 x cubed. And then just expand to get the result of the variable of x cubed over here. So you only have to expand 1 times 160 to the power of 3, the first, second, negative 3x, and then 60x squared. Okay, so we get 180 x cubed. So simplify this, what do we get? You will get negative 20 x cubed. Don't forget to write out another words, which is the coefficient of x cubed is equal to negative 20. That's all. Okay, don't have to write too much. Don't have to write in the full complete sentence. Okay, make your answer simple. Okay, use the simple ways to get the full marks. So yeah, this is how you perform the workings when dealing with the determination of the coefficient of x cubed. Alright, so yeah, let's move on to the next passing questions. Okay, let's move on to the next question, which is the question 21 from 9709, May June 2010, question 2, paper 13. Okay, for the first part, find the first three terms in descending powers of x in the expansion of the x minus 2x bracket to the power of 6. Okay, before we start expanding, okay, follow my ways like this. Construct a table. No need a complete table, just a simple one. Just draw a few lines over here. So what is the degree of first? First term is 1. Second, -1. And then sum. 6, 5, 4, 3, 2, 1, 0. 6, 5, 4, 3, 2, 1, 0. And what's sum? 6 minus 0, 6. 5 minus 1, 4. 4 minus 2 is 2. So this proves that the question was right because of each first few terms, okay, the degree is the power is decreasing. Okay, this is 0. This is -2. This is -4, -6, like this. So now you may start the expansion right now. Okay, it only wants the first three terms. So take first, second, third. Alright, at least you need to write out the term of the NCR and the each term with with its degree. Okay, this is as your base meta marks. So 6C0 x to the power 6 -2x to the power of 0 plus 6C1 x to the power of 5 -2 over x to the power of 1 plus 6C2 x to the power of 4 times -2x bracket to the power of 2 and so on. But following the marking scheme, okay, it doesn't show there's a 3 dots over here. But for me, it is best for me to encourage you to write the 3 dots. Okay, to illustrate that these expressions are just only the parts of this term only, this expression only. Okay, or the expansion. So evaluate and simplify it. You will get x to the power of 6 minus 12x to the power of 4 plus 60 x squared. Okay, so it is best for you to verify it all over again to avoid any mistakes. Okay, I don't think there's a mistake over here. Wait a second. Yeah, I was right. So yeah, let's move on to the second part. Find the coefficient of x to the power of 4 in the expansion of 1 plus x squared times the x minus 2 over x. And then with the degree to the power of 6. So just use the result from A, apply inside here. Okay, So since there is a given x to the power of 4, so we have to find out which has the x power 4 in order to form another terms of the with the x power 4, which is 60x squared over here. So this is why taking A level is beneficial for you. Because of first, create the result first. Okay, use the result from the previous part to solve for the next part. So write it out, 1 plus x squared, x minus 2x. But for this particular part, you don't have to write out the 3 dots already. Because of examiner assumes that you have understand these 3 terms, the first 3 terms are just only the parts of the expansion. Okay, 1 plus x squared, copy as usual, times, replace this as the result that we have done from A, not A is first part. So just only expand to get the term x power 4. So 1 times negative 12 power 4, as well as the x squared times 60x squared. Negative 12x power 4 plus 60x power 4. Okay, simplify it, you will get 48x power 4. So hence, the coefficient of the x power 4 is 48. That's all. Okay? So yeah. Okay, there's nothing to discuss about this question because the question for the binomial expansions requires you to be aware. Be aware of the coefficients, okay, as well as the degree. Alright. So yeah, let's move on to the next question. Okay, here comes to the next question. It is about the arithmetic progressions. Okay, question 23. So this is the puzzle questions from 9709, May, June 2010, question 3 from paper 11. Okay. The ninth term of an arithmetic progression is 22. Okay, write out the information first. So T9 is equal to 22, and the sum of the first 4 term is 49. So S4 is equal to 49. For the first part, find the first term of the progression. Arithmetic progression denotes arithmetic progression and the common difference. So the first part wants you to find what is A and D by using these two relations, these two informations from the context of the questions. So T9 we can express it as A plus 9 minus 1 is 8. So we can directly write A plus 8D is equal to 22. So this is your first equation. And next, S4 is equal to 49. Okay, this is 4 over 2, 2A plus 4 minus 1, which is 3D. Okay, so 4 over 2 is 2, 2 times 2 is 4, and then 6 is equal to 49. This is as your second equation. So now, find for the first term for me by using the elimination methods from your secondary school. This is the prerequisite topics from your secondary school. So 1 times 4 is equal to 4A plus 32D is equal to 88. This is as your equation 3. Oh wait. Yeah. So this question does not matter the order of finding the common difference and the first term. Okay? As well as both first term and common difference are found. So yeah, take the third equation minus the second equation. Okay, so you will get 26D is equal to 39. So find for D. You will get 3 over 2 as the common difference. This is your first final answer for the part 1. Okay, draw a line. Okay, because of in your external exam, it gives you a line like writing the essays, but it's actually not asking you to write an essay. Okay, so the lines are for you to perform your workings. So draw a line in case there's a insufficient space. So sub D equals to 3 over 2 into, maybe I choose first equation to get the first term, which is 8. So 22 minus 8 times 3 over 2, the A is 10. First term is 10. Okay, that's all for the first part. Move on to the second part. The nth term of the progression is 46. Find the value of n. Okay, so Tn is equal to 46. So since you got the A and D from part 1, why not just apply it? 10 first term, n minus 1, okay, n to be found, and then multiply by the common difference, 3 over 2. Next, solve for n. So, eventually the n is 25. Okay, so that's all for this question. Okay, let's move on to the second last question among our exercises discussion for chapter 6. So this is question 24 from 9709, October, November 2002, question 2 from paper 1. Okay, so this question is about the geometric progression for which the common ratio is positive and has a second term of 18 and fourth term of 8. Okay, write out the informations. R is greater than 0. T2 is 18 and T4 is 8. Okay. For the first part, find the first term and the common ratio. I think there's a typo over here. Okay. So cancel it out. Replace it as ratio. Okay. There's a corrections of the progression. Okay. So use the two informations above. T2 is equal to 18 and it wants to find what is A, what is R. Given that the R is greater than 0. So usually this involves quadratic equation or the polynomial equations because there's a 2, degree of 2 and 4 for the common ratio. So here is it. A, what is R? 2 minus 1, so AR equals to 18. So this is your first equation. T4 is equal to 8. Okay, so A times what is the R? It is 3. 4 minus 1, 3 equals to 8. Equation number 2. Alright. And then take the equation 2 divided by equation 1. AR cubed divided by AR is equal to 8 over 18. So as you can see, the fourth term is less than second term. We should aware that the R isn't greater than 1, but less than, or the R is less than 1. Okay? So to avoid, actually you may cancel the R because of R cannot be 0. As the question has implied that the R is greater than 0. So cancel cancel it to get r squared is equal to 8 over 18. Okay, you can also simplify 8 over 18 is 4 over 9. Okay, so take the square root at both sides. So we get plus or minus 2 over 3. But since the r must be positive, so r is 2 over 3 as your final answer. Okay, and now sub r equals to 2 over 3 into 1. Okay, because I want to speed up my workings, speed up my answering rate. So what is a? Okay, just simplify it. Solve this equation. Okay, to get a of first term is equal to 27. That's all for this part. Okay. Part 2. The sum of infinity of the progressions. So S infinite is equal to, what is the A? 27. R is 2 or 3. It is valid to use the sum of infinity because of the modulus of the R is less than 1. So A is 27 divided by 1 minus 2 over 3. Okay, apply the formula properly and press it, key in your calculators. You will get 81 as your final answer of the sum of infinity for part 2. Okay, so yeah, that's all for this question. Now let's move on to the last question. Last questions. All right, here comes to the last question of the among the discussion for the exercises for chapter 6. Question 30 is the past questions from 9709, October, November 2010. Question 5 from paper 1-2. Okay, so some of students think that this appearance this question seems very hard, but if you keep practicing, okay, the hard changes to wasting time. Okay, so you are able to dealing with the challenging questions naturally. Naturally. Right? Part A. First term of the AP arithmetic progression is 161. Okay? And the second term is 154. Okay? And given that the sum of the m terms is 0, now you find the values of the m. So first thing, you can find the common difference first, which is 154 minus 161. So the common difference is negative 7. Okay? So Sm. Sm is equal to 0. So since this series is arithmetic progression, just apply the formula. Okay? I want to remind that for dealing with the series question, okay, if you recognize the formulas of the AP and GP, use it then. So n over 2, times 2 times the first term plus m minus 1. So as you can see, there's a multiplication of m and m. So we can confirm it as we have to solve the quadratic equations. So if you want to get at good at maths, you must have a good observations as well as the predictions of your workings. Okay, so what is the common difference, which is negative 7, is equal to 0. So simplify it. You will get 161 times n, because 2 over 2 is cancelled out, negative 7 over 2 m squared plus 7 over 2m. Okay? So simplify it, you will get 7 over 2m minus 329 over 2. Okay? So you will get 7 over 2m. Okay, factorize it as 7 over 2m, m minus 47. But it is impossible for the m is equal to 0. So m equals 0 is rejected. Okay, however, there's another scenarios of the factorization of this, which is m minus 47 is equal to 0. So the m is 47. So this is the best answer for the first part, for the part A. Okay, m equals to 47 as your final answer. Alright, so yeah, let's move on to the B. So B is about a geometry progression. Okay, a geometry progression in which all the terms are positive has the common ratio of R. So R must be also positive as well. Unless your first term, oh no way, A is also positive as well. Because of for all the terms are positive. Okay, the sum of the first n terms is less than 90% of the sum of infinity. Show that the Rn is greater than 0.1. So you must prove from this information to the result of this inequality. Okay? So given that the Sn is less than 90% of the sum of infinity, so put the lesser inequality sign 0.9 since it is 90% of the sum of infinity. So use the formulas of Sn and S infinity simultaneously for these questions. Okay? So this you have A times, but we can convert as for the sum of infinity, the R must be between 0 to 1. 0 and 1. Okay, in order for the modulus of R is less than 1. Okay? So we have 1 minus R to the power of n over 1 minus R times is lesser than 0.9 of the A divided by 1 minus R. Okay, as you can see, the 1 minus R, A can be cancelled out. 1 minus R is cancelled out as well. So 1 minus R n is less than 0.9. Okay, so move the 1 to another side. So minus R to the power of n is equal to negative 0.1 if, if not mistaken. Okay, and cancel the negative, but if you cancel the negative, you must switch the sign of the inequality without the equal sign. So the Rn is greater than 0.1, therefore shown. Okay? So yeah, we have ended the discussion of this question. Also, we have ended the exercises discussion for chapter 6. So yeah, I declare that chapter 6 series has officially ended. So now let's move on to the summary for chapter 6. Okay, here is the summary for the chapter 6 series. First, okay, for the binomial expansions, you still have to know there's a factorial presence inside the NCR, but generally the binomial expansion, the binomial theorem or binomial expansion is only has a plus b bracket power n. Why there's a by words? By means 2 in the Greek words or the Greek prefix. Because of there are only 2 terms. Okay? That is valid to use the binomial theorem. Okay? Second, arithmetic progressions. Okay? A is T1, common difference, Tn minus 1. Okay? Tn And then the n term of the arithmetic progression, formula, sum of the first n term, formula, okay, as well as the geometric progressions, common ratio r is equal to Tn over Tn minus 1. Okay, n term of geometric progression, formula, first n term, formula, as well as the sum of infinity, it's formula as well. Okay? So you have to know how to utilize the formulas of the series correctly and properly. Okay? So yeah. And the last summary is, before we end this video, is arithmetic, plus and minus, geometric, multiply or divide. Okay? So it is best for you to imply the aberrations of AP and GP for the examiners to understand. Okay? So yeah, for the sum of infinity, the common ratio, the modulus of the common ratio is less than 1 in order to converge it. In order to let the series converges. Okay, so yeah, it comes to the end of this video. So in the next video, we are going to enter the further maths topic, which is the further pure mathematics one. Okay, after viewing this video, please make sure you leave a like with a subscribe button as well as the bell for the further updates. So yeah, in the next video, we are going to enter the further pure mathematics 1, chapter 1, roots of polynomials. Okay, so I will see you in the next video. Thank you. Bye bye. Thank you for watching this video. Be sure to like and share this video and subscribe to this channel. I will see you in the next video. Goodbye.